Hello everyone, I hope you all safe and you all doing fine and your families are also doing fine. As you know, because of this coronavirus, we are not going to be able to actually have our school for 2 weeks, and during that time, we will continue to our lectures online, and this is going to be the first one. And in this lecture, I'm just going to go over the PowerPoint. So you have this lenses chapter in your booklets right now. I'm hoping you guys didn't lose it somewhere. Even if you did, I have shared it on Parent Square, but I will also be posting those in Google Classroom. So you will be able to follow everything through Google Classroom. I'm going to be sharing the links of the videos, the PowerPoint links, and the booklets links. And I'm going to be adding new assignments because the assignments that we have in our booklet might be not for all of them, but for some of them they might be a little bit longer than it should be. So I will try to adjust it, so if there's anything new, I'm going to be posting it over there and I'm going to give you descriptions underneath. So if you guys have any question anytime, you can just put the comments under the video, because I'm going to be putting the videos on the YouTube, or you can just ask your questions through Google Classroom. Alright, so I hope everything's going to go well. This is going to be new for me. Let's hope that it's not like as boring as it would be. Alright, so we're going to start with lenses. So last time we had talked about mirrors, and in mirrors we had reflection. But in lenses, light rays are not going to be they're not going to be reflecting, but they're going to be refracting. Alright, so let's get started. So we're going to start with the bell work. You have everything that I'm going to cover today in your booklet. So I want you guys to go over the booklet and finish your notes. Alright, so match the pictures with the words below. So we have converging, diverging, concave, and convex. And we have 4 different pictures. So in 2 of them we have 2 mirrors, and in 2 of them we have light rays. So basically, remember, we had those names. 2 of them was because of the shape. So convex and concave, they were because of the shape, and diverging, converging, that's basically what the material does to the light rays. So if you think about that, converging and diverging. So remember, diverging from diversity, so it's basically going to spread the light rays. So that's what it does to the light rays. So diverging in that case is going to be matching with this last picture, because as you can see, the light rays are basically diverging. It's not too much, but it is. So then converging will be the opposite, so it's going to be basically putting the light rays together, so it's going to be the second picture. Concave and convex, they are because of the shapes. So cave, remember I said it's going in. Anything that curves in is going to have the shape of concave, or the name of concave. So this concave in this case is going to be this first picture because it's curving in. And anything that curves out is going to be convex. So basically that's how it's going to be matched. Converging second picture, diverging last picture, concave first, convex third picture. Alright, convex lenses. So the names are again going to be a little bit confusing because we're going to use convex lens and convex mirrors. So they're going to have same names, but the properties will be the exact opposite. So let's go over it. Convex lens is basically combination of 2 circles, but in the center you have basically a transparent material which can refract the light rays. So that's basically how we create the convex lens. So why is it convex? Remember, it's basically shape is convex because it curves out. So that's why we are going to name it convex lens. And because of what it does, it's going to have the name converging, because that is basically converging the light rays. It's not diverging, it's basically converging the light rays. So that is why it's going to have converging lens or convex lens. So what makes it convex lens? This is basically the rule. They are thicker in the center or than edges. So basically, you see the edge, the top is basically thin, the center is thick, so that's what makes it convex lens. Alright, so parts of a convex lens is pretty similar to the mirrors. The only difference, we are going to have two circles this time. So that means we are going to have two center of curvatures, C1, but we are going to use the same circles. So C1 is going to be basically the mirror image of this thing on both sides. Alright, so we basically have two circles, two centers, two focal points. But besides that, everything else stays the same. Half of the center of curvature is still the focal point. Nothing else is changes. All of the names are the same. Imaginary line is the principal axis, and everything is the same. Alright, so remember we also had principal rays in the mirrors, so we're going to have those principal rays in the lenses as well. So in mirrors we had the reflection, in lenses we're going to have refraction. So I'm going to be using ray 1 and ray 2 all the time, but if you guys need, ray 3 will also be a principal ray. So any ray that is going to go straight, it is going to basically refract through the focal point. Alright, this is number 1 principal ray. So any ray that is parallel to the principal ray, they're going to go through the focal. And second one is simpler. Any ray that is going through the vertex or pole, they're just going to go straight. They're not going to refract at all. Or third one, again, I'm not going to use this, but if you want to know, any ray that is going through the focal point, they're going to refract parallel. Alright, so these are the principal rays, and we're going to need those to basically create the images. Because remember, any two rays intersect, we are going to have the image. So I want to remind that again, the image will be formed where any, it doesn't matter which two, but we're going to need two, since we are using lenses, refracted rays, and we are looking for the intersection. Alright, let's get started. So if you have an object that is beyond the center of curvature, then how are we going to create the image of this object? So like we do in the mirrors, we're going to start with the top point again. So what we need two refracted rays. So that means we're going to send two rays coming out from this point. And our principal rays are going to help us for this. So like I said, I'm going to use ray 1 and ray 2. What is ray 1? Parallel. The other is going to the vertex. So if you basically send one parallel, how is it going to refract? Through the focal. The one that you send to the vertex is just going to go straight. So once you have those two rays, where are they going to intersect? They are basically intersecting at this point. So the image of this point is formed right here. So once you have this one image, or image of one point, you can basically continue to get the images of a single point, but you don't really need to do that. All you have to do is just draw a straight line from that point to the principal axis and place your arrow wherever your point is. So since my point is here, then my arrow is going to be in this part, so my image is going to look like this. Alright, so once we get the image of this top point, we basically figure out where the image is and how it looks like. After this, we are going to be able to figure out all of the properties. So first thing that we are going to look at, is it real, virtual? So remember the rule for real and virtual. If refracted rays, So in my case, those green lights are my refracted rays. If refracted rays themselves are intersecting, which they are, then the image is real. And then the rest is just going to be basically looking at it and then deciding what they are. Smaller, original image object is 2 units. My image is just 1 unit, so it's smaller. It's inverted, so this top point is right here. It's below the principal axis, so it flips, so it's inverted. And the image is in between C and F. How do we know that? So this is F, this is C, my image in between them. So that's how we figure out the properties of this image. Alright, so if you go forward, then you're going to do the same thing for every one of them. At this point, I want you guys to basically stop the video and then do the sketches and then move on, because you guys are going to need those in your booklets. Alright, so if you have the object at the center of curvature, then we do the same thing. We send 2 rays, one parallel, the other's to the vertex. Vertex is going to go straight. The one that is going parallel is going to refract through the focal, and then you basically locate where they intersect. And if you look at it, then you will be able to tell the properties of it. Again, refracted rays are intersecting, so it's just going to be real. Alright, so drawing, it seems like it's kind of a little bit like in front of the center of curvature. It's not exactly at this point. Yes, that's kind of true, but theoretically, any object at the center is going to have those properties. So, and the reason that I don't have perfect intersection at this point is basically the drawings are not like perfectly well drawn. That's why it seems a little bit off. But what you need to know, it's if you have an object at the center, theoretically, the image is also at the center. So again, it's real because refracted rays are intersecting. The height, 2 units is the same. It's inverted. You basically come out from top, but you basically intersect in the bottom. And location is exactly at C. All right, so these are the properties of this guy. If you move forward, do the same. Send 2 rays parallel to the vertex wherever they intersect. Let's look at the properties. Again, refracted rays are intersecting. It's real. This time 2 units, image is 3 units. It's larger. It's basically formed below the principal axis. So it's inverted. Where is it located at? It is beyond or behind center of curvature. And next one is the critical point. If you are at the focal point, then what's going to happen? In this case, you're going to have 2 light rays that are parallel to each other. So theoretically, there is no image formed at this location, or formally, it's formed at infinity because those 2 light rays goes to infinity. So light rays are parallel, so we don't really talk about properties of the image because we don't really know how it looks like. So there's no image, so we don't really talk about properties of it. Alright, if you go even further than a focal point, then what's going to happen? This time it's going to be a little bit different. So this time, the light rays, we are still sending the 2 same light rays. One parallel, it's going to go refract through the focal, the other is straight to the vertex. But this time, those green rays are not going to be able to intersect. But what's going to intersect? They are basically projections. So if projections are intersecting, then that was the rule for virtual and real. Not the rays themselves, but their projections are intersecting, so it's becoming virtual image. And again, it's going to be 4 units, so it's larger than the original object. So this time, the object, the point that we had over here, it's going to be appearing right here. So once you draw the line straight to the vertex, principal axis, then you see this is where my arrow is, so that's my basically image. So that is why it is going to be upright. And where is it located? So it's basically in front of the lens. So this is the front portion of it, so it's in front of the lens. Alright, so these are the properties of images that is created by the convex lens. So, but there is a pattern in between them actually. So if you go for, if you look at them all, we will be able to see a pattern. So if you have an object starting from like farther away from center, and as it get closer and closer, let's see what pattern do we see in the image. So image starts in between center and focal, then it goes to the center, and then it goes even further. So as you get closer and closer, your image is getting farther and farther, but your image size is also getting larger and larger. And technically what happened is, as you get closer and closer to the focal point, you see you're getting closer and closer to the focal point, and at this focal point your image is at infinity because you're getting closer, your image is going farther and farther away. And at the focal point, it's basically the critical point where the image goes really, really, really far away, which we call it infinity. Alright, so basically this is the pattern. As the object gets closer and closer to the focal point, image gets farther and farther away from the lens, and the size is also getting larger and larger. And if you want to think backwards, let's say this object is not at the center, it is far behind, like far behind the center of curvature. What will be the image? So if you think backward, then you're going to need to go backward basically. So as you get closer and closer, or as you get farther and farther away, your image will get closer and closer to focal point. So if an object is really, really, really far away, then the image will appear at the focal point. Actually, if we were in school, I would be able to show that with a demonstration, but we don't have the material, so I'm not able to show that to you. And focal point is the critical point, and after focal point, the image inverts, and then, or it gets upright, and then it becomes virtual. Alright, so what about concave lenses? Concave lenses are going to have two names, concave and diverging. Concave is because of the shape, and diverging is because what it does, because it's going to diverge the light rays. And what makes it concave? Thinner at the center, and then thicker at the edge. Thin, thick. That's what makes it concave lens. Alright, properties are the same. You still have two circles, two center of curvatures, but they are two same circles. Nothing else is different in here. Alright, for those, we still have principal rays, and again, I'm going to be using ray 1 and ray 2. You don't need to know anything about ray 3. Any ray that is parallel, it's going to diverge this time, not converge. But what's the rule? When it diverges, the projection will go through the focal point. And any ray to the vertex will just go straight. Nothing is changing. So once you consider those two properties, then you're going to be able to have one set of rules for the images for concave lenses. And one ray parallel diverges, the other goes to the vertex, goes straight. So as you can see, those two rays are not able to intersect, but their projections are intersecting, so that makes it virtual image. Image, as you can see, it's here. It is smaller than the object. It is upright, and it's in front of the lens. So if you look at the properties of it, virtual, smaller, upright, in front of the lens. Alright, math of the lenses, it's exact same that we had in the mirrors, so nothing else is changing. All of those rules, you will have three equations only, nothing else, but the math of those will be a little bit difficult, but I will try not to have too difficult examples. But if we have it, I'm going to show you how to solve those. Alright, again, one correction needed, so that needs to be not position of the image, this is going to be the height height of the image, and this is not HO, this is HI. Alright, so height, so these are the important notes that you guys need to know. Height below principal axis is negative, so this region is your negative region for the height. And position in front of the lens. So for mirrors, it was behind the lens, but for lenses, behind the mirror, for lenses, it's basically in front of the lens is going to be the negative region. And focal length for concave lens will be negative. That's what you guys need to worry about. Alright, so this is it for the lecture. Again, I will try to keep it short, but it might not be as short. But I'm not going to have any longer than probably 20 minutes. I know it's too much, but I try my best to make it short. So if you guys have any questions, you can basically ask that through Google Classroom or over to YouTube. Both are going to be fine. And I will be solving the questions separately. So if you guys have any questions about the question alone, then you will be able to actually have your comments about those separately. Alright, I hope that was helpful. I don't know when we will see you again, but I hope to see you soon, and I hope you guys all doing fine and staying safe. Alright, see you guys later in my next video.